Good evening to one and all present here. I, Richa Kaushik, on behalf of GDSC BVP, welcome you all and our speaker, Mr. Rajat Arora, for this session on Introduction to Kotlin. I thank you all for joining us here. Mr. Rajat Arora is a senior software engineer working with Berenberg Bank in Germany. He is currently leading the digital transformation tech team technically. His team is responsible for driving the digital transformation and moving away from the manual processes. He is skilled in all aspects of software development lifecycle with everyday language experience in Kotlin, C Sharp, TypeScript, SQL, and frameworks like Spring Boot, .NET, and Angular. Apart from coding, he enjoys playing guitar, listening to music, and cooking. Now, without much ado, we would be welcoming Mr. Rajat Arora to start with the session. Sir, please.
Good evening, everyone. Uh, so, how are you guys doing? Am I able to see any comments or hear anyone over here? I'm not sure about it. Richa, maybe you could tell me something about it?
Yes, sir, doubt session will be asked here in the chat section
Okay, all right.
after the
Perfect.
session. Yes.
Perfect. So, all right, I think we can already start with the presentation. I've prepared something for you guys. And I think I'm going to share my screen with all of you. So, is my screen visible? I hope I hope it should be. So, okay, so today's session is about introduction to Kotlin or getting started with Kotlin. So, something about myself which I has already kind of introduced. Maybe I would like to give some words or maybe introduce myself to you guys. I've completed my Bachelor's of Technology Computer Science from Guru Gobind Singh University of Delhi. And then I moved forward and worked with Infosys for somewhere around 2 years. I was I had my training session in Mysore and then moved to Pune. And then eventually, after Infosys, I joined Megero. And there I worked for 1 year and 10 months, around 2 years of time of range. And then moving forward, I moved to Germany to work with Edmond Softwares. And then after that, for working there for around 10 months, I moved to Berenberg Bank and I'm currently working over there. Currently, I have a role of software architect in my team, and I'm managing 5 projects altogether with a team of around 5 people over here. And we have, as Richa clearly mentioned, that day-to-day experience in working with Kotlin as a programming language. I've also had experiences with other frameworks and languages such as C Sharp. I currently work with Angular. I'm working with Spring Boot as well and some testing frameworks. So all of this different parts of the languages, different types of the frameworks. Yes. So what is Kotlin? Kotlin is an open source, statically typed programming language that targets JVM, Android, JavaScript, and native development. And this is basically developed by JetBrains. And it started as a project in 2010, but it was officially released in February 2016, the version 1.0. So, is Kotlin an object oriented language or a functional one? I think Kotlin is both an object-oriented and functional programming language. We can use it in the form of using the OOPS principles, or if we kind of want to work with some functional programming constructs, we can also use it in that way. So, it if we want to use it in the form of a functional programming, basically the first class support is offered in terms of higher order functions, in terms of function types, lambdas. So it's good for both of them. I think we in our current project use it as an object oriented programming language, but definitely some people who like to go the functional way, it's also a really good language for that. Moving forward to the next slide. Kotlin and Java. So I think many people ask this question. They have this reluctancy that I already work with Java, and I do not want to move to any other language. I'm quite comfortable with it. Why should I learn any other language when Java is currently being used everywhere, and every kind of, like, almost a lot of projects are being developed using Java. So why should we do that? I think a very good reason for that is what I could clearly mention in this slide, which we can discuss about. Kotlin, as per my experience as well, roughly cuts 40% in the number of lines of code, the way we develop the code. So it's a really nice improvement, a really big improvement in terms of the structure which we have, and in terms of the things, the way we are write our code. It's more structured and it's more concise, and it's also more type safe, as it mentions. It has support for non-nullable types, which makes application less prone to NPEs. This is null pointer exceptions, which is like the most famous thing which anybody who has experience with Java as a programming language kind of knows about. That most of the issues people deal with, people nowadays make memes out of it as well, that okay, a null pointer exception and all of these things. So yeah, Kotlin has a really nice support in terms of dealing with null pointer exceptions. And regarding the interoperability, so I think Kotlin offers a really nice interoperable environment. It is compatible with JVM. So what does that mean? That means that if we already have a project which is developed using Java, we are able to write code with Kotlin as well, because ultimately that gets converted to the same type of the Java bytecode. So eventually you can have a project which is half built on Java and half built on Kotlin. Or if you want to move towards Kotlin, like in future, in those terms, you can also start writing and converting your code step by step, and eventually move to Kotlin completely. That is also really helpful in that regards. Also, one more thing, when we use Kotlin in our project, we are able to call the Java code seamlessly. And when we use Java, we are able to call Kotlin seamlessly as well. So it's also really interoperable and really good. So what can I use Kotlin for? That's the first question, which is generally very common. We can use it for Android development, where Android since 2017 offers first-class support for Kotlin as a language for their platform. Then we can use it for server-side development, which currently my team is using at Berenbeck. We're working with Kotlin in terms of implementing APIs and all of those standard things when we implement a backend. Then client-side development, there is something called Kotlin JS, which is a plugin which we can use, and we can convert our code written in Kotlin to ES5 compatibility, and it can run in browsers afterwards. We can also use it for the native development, which targets the embedded or the iOS, basically for the environments which do not have virtual machines and where we do not have any virtualization available. So it directly targets the base platform over there. Some statistics. I think this was the latest statistic which I could find on the official website of Kotlin, which goes up to 2021, which was kind of a prediction, but I think as per the latest stats, it is currently true. It started off, like, they started recording this in 2019, it was 3 million Kotlin users, then it went up to 4.6 million, and in 2021 it was predicted to be 5 million. I think that's pretty much true, because it has become quite popular nowadays, just because after Android started offering the first class support, a lot of people have moved to Kotlin as their preferred language. So let's jump into code. I think while coding, prefer generally a dark theme. So I think you guys would also see that dark theme going on now, because I talk about code over here, and I think it's a bit easier for us to understand if we do it using that way. Okay. So moving forward to the functions part, I I hope you all kind of know something about some programming language, at least have a basic understanding of any one of the programming languages which you must be working on. Where we use functions to kind of have some repeatable code present in terms of a small section which we can call again and again, and which increases the readability and reduces the redundant behavior and the redundant lines in our code. So in Java, that is how somehow we write our function. It has an access modifier, then it has the return type of it, the name of the function, the arguments to it, and then the return value inside of this. In Kotlin, we have something similar to it, where we do have the return type, but that return type gets moved to the end of it. using colons. And then it looks pretty similar to it. And then the type of the parameters which you pass to the function, it also kind of shifts after it using a colon. So it looks pretty similar to it, pretty similar to the Java code. So I already kind of explained that we have a function. That is how we declare it. And then we have these parameters over here, which, by the way, in Java are like this. And then this is the return type of that particular function. And then, as you already have noticed, we generally use semicolons when we write code in Java. But I think Kotlin goes by the way that since it is quite a new language, it was introduced quite newly after 2010 or 2016 February officially. It is more developer centric, if I would mention it. It does not see the need of having semicolons because the developers felt like it was unnecessary to have semicolons over here. So you won't find semicolons in Kotlin. And then this is the return part where you are performing a sum on these integer parameters and returning it. And this is another kind of a shorthand syntax where you can also define the return of a function. Like previously, if I would show you the previous slide, we had these curly braces over here, and we can use a return statement inside these curly braces to return the eventual result of this function. But in the next section, we can see that having the return type over here, we can just place an equals operator over here and then perform whatever operation we want to perform on the right side. So it's also pretty concise the way it looks. That is developed if you want to just have a one-liner function which does not have a lot of logic and performs very basic functionalities. Consider something, maybe it's logging something or adding it up, which you already see on the screen. There are multiple use cases which you could use when using a function like this. Moving forward to the next part, function arguments, which we kind of already spoke about in the previous section, but I think we'll go a bit deep dive in this one. In Java, the way we have the pass arguments using this, so it's a function declaration. It accepts string as a parameter, integer count, and then string separator, and then it has some implementation. Plus, we call this repeat function over here using a string, an integer, and then again a string over here. So it's pretty straightforward. For each of the parameter, we have an argument over here which maps to each of these parameters. Pretty straightforward. Moving to Kotlin, it also looks exactly the same way. So we are doing it over there, but it does not have any semicolon in the end. Okay, moving forward to the default parameters. So for example, over here, we see that Java function is kind of declared like this, and Kotlin function is kind of declared like this. Sometimes there must be a scenario where we want to declare an optional parameter, which you can say. So an optional parameter is a parameter whose value you can omit if you don't want to pass the value of it, and which is represented by this using an equals operator over here. So if you don't want to pass the value of count parameter over here, you can just say equals 3. So if you do not pass anything over here, it would presume that you meant that you only need 3, and it would actually by default take the value 3 from over here and use it inside the function as it is. Quite amazing, right? Quite useful, I would say. And for example, in this scenario, if you see that if you call this repeat function, if you call the first part, which is a string, and you pass ABC in there, and then the second parameter is count, you see that if you only pass the second parameter after the first one, it would only take the second parameter and not force you or tell you to pass the third parameter. That is the use of optional parameters or optional arguments, which you can use, and you don't need to pass it all the time. Also, you can make use of the named arguments, which is named using count. For example, consider one scenario. You have a function, and there you have an option to pass, for example, 5 parameters and 5 arguments to it, right? And after defining each of these, giving them each of these default values in the declaration of the functions, you could see that it might be sometimes required for you to just pass the third one and not the first and second one, or maybe first and fifth one. It could be a different constellation depending on your requirements. And there, it would be really handy to pass it using a specific name of that particular property, of that particular argument which you want to pass. That's what we are doing it over here. And as you see over here, we are also passing the separator over here. Or, that I already mentioned, that if we do not want to pass the count, we just pass separator over here. Moving on to the next section, which is variables. So basically, in Java, the way we declare variables are defined over here. We have integer, like the type of the variable, the name of the variable, equals operator, and the value of the variable, or the same way as string. Pretty simple, pretty straightforward. In Kotlin, we have something which is called val. This might hit something, or this might look something familiar. You might have heard in JavaScript we have var, we have let, and all of these const. The way in Kotlin we have something called val and var. So here I would explain in detail about what is var and what is val. Let's just first see the syntax of it. So over here we have val a and the type of this particular variable, which is a, and we assign it a value. Val, which I already told you what is it about, and then we have the type of it, and then we have the value of it. All right. In the last step, if you see that we are kind of defining the types over here, but when we actually start to develop the production level code with this, and we actually start to write some code, and when we use an ES linting or some sort of linting or some sort of compile time checking, and we some sort of use an IDE. Generally, an IDE always tells you to avoid passing the types to it when we can infer the types from the type of value we are assigning to this particular variable over here. So as you can see that we have val a equals 1 or val b equals this. So Kotlin is intelligent enough to know what type does your parameter use, what type does your variable use, and that is how we kind of deal with it. Moving on to the next step, immutability. So it's about immutability is about that you once you assign a value to a variable or create a variable, you're not able to change its value afterwards. It's something like a final keyword which we have in Java, that whenever you assign it a value, you cannot change it later on. That is somehow something like this over here, that whenever we have a val declared over here, well, x equals 1, the type would be input, it's an int, and then x equals 2. This would be a compile time error because val is immutable. And there comes to our savior, var. This var we use whenever we want to declare variables whose value could be changed in future. That means mutability. That means they are mutable in nature. So if we create a variable with var y equals 5, and then we assign another value to it, y equals 10, then it's completely okay with it because we are declaring it with var. So the guidelines of Kotlin, generally the good way of coding is that we always should start with val, we always should start with immutable variables, and then eventually we should move to var, and only when necessary. Null safety, which we talked about in the starting and kind of teased a bit, that it's about it deals with null pointer exceptions, which Java fails to do so in a more elegant way. So we're going to see in further slides how does it deal with that. So over here we have the null safety, where we mentioned that var str of type string is equals this value x, y, z. But what if string equals null? What happens? It would be a compile time error because Kotlin, sorry, Kotlin deals with this in a very elegant way, that whenever you want to have a null safety implemented, or you have to have null safety implemented, or whenever you want to have a variable which should contain null as a value to it, you always should make it nullable. Without it, you You cannot assign null to it. And that is why it fails and gives you a compile time error over here. And which is a really great feature, I would say, because it prevents your null pointer exceptions. It's really amazing the way it is developed. You see, as we discussed above, that it has to be a nullable. How? We use a question mark over here to tell Kotlin that, okay, the variable which I'm declaring over here, string or str, is of type string, which could also receive a null value into it. That is how we kind of define it over here. And then Kotlin understands, okay, I understood your motive, I understood the way you want to code it. I will let you assign null to it. That is how it handles null pointer exceptions on the compile time level. Function get length. So this is another example of null safety, where if we have a function called get length, we pass a value to it, and we have a nullable parameter to it, and then we also have a nullable return type to it. What happens if we use return str.length? What should it be like? It should again, as guessed right, a compile time error, because here we cannot straight away directly access the length of a string. It could be possible that the caller of this function could be passing null to it. And that is why we cannot directly access this. And if we try to directly access this, it could in runtime result in runtime null pointer exceptions. And that is how Kotlin kind of deals with it. It would tell you in your compile time that, okay, there is a problem to it and it is not working the way it should be. How do we handle it? We handle it using this. So whenever we receive the value of a string str, we use if string is not equals to null, return string.length, otherwise return 0. So using this, we would kind of get to know what is happening with it. What is happening over here? Like, I mean, it tries to get the value of string, and if string is not equals to null, that means string contains a value, then you can actually access the length. And if it is actually null, which is the case, if it goes outside the if, then you can return it as a 0 because there is no length of it, but obviously. So here, it could be either done using else, or you can straight away return it like that. So here, Kotlin kind of performs smart cast. It's another feature of Kotlin as a language where it checks, okay, if it's not null, it performs a cast of it and makes it non-nullable, and you kind of access the value out of it using str.length. So this is something which is called a safe call operator, which is available in Kotlin. And I think some people who work with TypeScript would also know something about this as well. We have a safe call operator the same way implemented in TypeScript. And that is why I think, in my opinion, Kotlin kind of resembles the code the way we write it in TypeScript as well. So if somebody who wants to work on full stack and work with backend as well as the front end, and would prefer to work with Kotlin and TypeScript together, I think it would make the lives of those developers really easier. Like the way we are working with currently Angular, TypeScript, and Spring Boot and Kotlin, it makes our life pretty easier because the way we use this language is quite similar. So over here, what does this do? So the safe call operator, what it does is, it would either, if, for example, string exists, it would try to access the length value out of it. And if the string does not exist, then it would straight away return null out of it. It would not try to access the value of length and would straight away go and return the null. And since we have a nullable return type of our function, it would easily allow us to return a null to it. And that is how the safe call operator kind of works. Quite handy, because the code which we wrote previously, line 1, 2, 3, and 4, we are avoiding those lines of code over here. And we are just using one line of code to write all of this stuff, all of this logic which we did previously. Now we have something called Elvis operator. Okay, what is this Elvis operator? For example, whenever we consider a scenario, whenever we see, okay, the value which we are trying to access could be null. And if it could be null, we can implement a different logic. I mean, we can return something else. Like, for example, the caller of this function does not want to accept null. That is why we make the return type of it as non-nullable. And over here, we could make something like string dot length. And if that is null, we use this else operator over here to return 0 in place of null. And that would make the caller receive 0 whenever there is no value of the string. I think it should be pretty much clear in this regards to null safety. And then we can have null safety on multiple levels as well implemented. So we have an example over here in terms of Java as well as Kotlin. We have the similar methods implemented where we have a complex type which is user, which is like it could be a class, it could be an interface which we pass over here, and then we try to check different things. Okay, if user is not equal to null and get address is not equal to null, then try to get the zip code. Otherwise, return null. And over here in Kotlin, all of that could be done in one line of code using null safety operator, which we discussed about. So it's pretty useful. You see the amount of improvement which it offers us. It's really amazing the way Kotlin is developed and the way we can reduce the number of lines of code over here. So over here, as we already knew that previously, we could convert the curly braces into equals. That's what we have done it over here. We have equals and we are returning it to user, question mark address, question mark zip code. So one line of code, and this looks really, really slim in Kotlin. Moving on to the next step, string interpolation. That is something which we commonly use whenever we want to log something, return something, or perform some sort of operation on strings and add something to the strings. We use string interpolation, and the way we do it is using the plus operator. So whenever we want to interpolate some over some strings over here, we use return song id plus, and then the real value of id, which we have the real value of title, real value of author. So these colons represent the string, and these things parts over here, these represent the value of that particular variable. And that is how we kind of do it in our Kotlin code. We can use string interpolation, something like using a dollar. And using a dollar, it would by default understand that, okay, by dollar, you mean that you want to access a variable which exists in your class or which exists in your file. And that is how we kind of achieve that. Here as well, you can see that you can perform all of that function in one single line. Pretty amazing if you compare it with the Java code, which is here, and if you compare it over here in terms of Kotlin. Classes. The way we develop classes in Java looks something like this. The access modifier, class, name, and then the name of the class. We have some properties of the class declared inside of it. String first name, string last name, integer of age. So if we want to see that we have these properties over here on the top, these are different getters and setters developed in order to access these properties or set these properties. So we have one constructor over here which sets the values of these properties. We pass something over here using first name, last name, age whenever you try to create an object of this user class. And here you assign the values to it. And the next step is like you are trying to access the value out of it using get, set, get, set. It's proper normal getter setters of Java class. It's 53 lines of code. Not so good. Let's see what Kotlin offers us. Moving on to the next step. These are some basic implementations in the Kotlin class. For example, if you want to do something like this in Kotlin, you can do the same way as this. You create a class, you have these things, these properties of the class available over here. Then you have a constructor which assigns it a value to these properties. You have a method called equals, which compares if two objects are equals or not, because these are complex types. We need to give it an equals variable the way Kotlin compiler should be able to compare that, okay, if these objects are equal or not. And then we have something called hash code, which has to be overridden over here. Then we have toString, which we saw it in previous step. So all of these things are a part of the Kotlin class, the way we develop. And now, for example, this part of the code which we have, the properties declaration and the assignment of the constructor could be moved into one small section with just one line of code, which is like this. You can move all of this up top over here. By this, it would mean is Kotlin is intelligent enough to know and to understand what you want to achieve over here. Kotlin understands that you want to have three properties in your class user, and plus Kotlin wants to understand. Kotlin understood that this is a constructor as well. As you see, class user bracket and bracket, it acts like a constructor as well, and it assigns those values which you pass to it to the properties of this class as well. Pretty amazing, right? Like all of this code which was there, around maybe like 11 lines of code, could be represented in just one line of code. That is already something like 90% improvement in terms of our lines of code. Okay, moving on to the next step, you see that we already used interpolation at the bottom to reduce the lines of code at the bottom. Let's see how can we further optimize this. Data classes. All of this functionality which you see in previous lines, equals, hash code, toString, constructor, properties, can be represented with just one line of code. Only one line of code. And that is the power of Kotlin, which we have over here. And that too, we have nullable types over here as well. So all of these things available in just one line. It's really, really good. How does it do? How does it achieve that? It achieves that using a data class. Data is the magic keyword over here. So what data classes means, data classes are the classes specialized for holding the value, holding the data specifically. It can be a DTO as well. DTO means a data transfer object with which you could receive the value from your UI, transfer the values from your backend to the UI whenever you call an API or something like that. All of that could be performed using data classes. Data class has all of those methods called equals, hash code, toString, and then copy as well. If you want to copy the value of it, you can use the copy method. So one line in Kotlin versus 53 lines in Java. I think it cannot be better than this. Like it is a good enough reason to maybe consider moving to Kotlin. If somebody would want to just at least try it. Next step. Kotlin also offers one support where we could have multiple data classes created in one file, which can be like models.kt. For example, you have different a data structure and you want to represent that data structure in terms of these one line of code like user, address, and zip code. You could just pack it up and save it in one single file. Properties. As we discussed about previously as well, briefly, that we have a class declaration over here. What we could do is that we could define them using var or val. So whenever we have var, first name, and string, what Kotlin in the background does is it makes it mutable. Obviously, it's var, and then it makes a getter setter out of it. And why does it make a getter setter out of it? Just to check that if that property is nullable or not. All of these things. And what about var, last name? It's mutable because we're using var. And then we have val age integer, which is read only, and which only has a getter because it is immutable. It cannot be set, as we already discussed about. The val is only declared once and it cannot be changed. That is why it is only read only, and that is why Kotlin in the background, when it compiles your code, creates only a getter. Here we can see an example out of it. How can we use them as fields? So we have function test, val user equals to new user object, user.firstname, which is here. We call the setter of it, and then we print the value of it. We can straight away access it using this $user.firstname. So the way we develop getters and setters can be also done like something like this in Kotlin. We can place a get at the bottom of it, and we can return something, a custom value, perform some custom operations over here. And the way we set value is we create a setter over here below these properties, and then we have a value which we can assign to the field, and by this the field refers to the field below which the setter is available. Extensions. Okay, I think you guys might have heard about extension functions if somebody has worked with, I don't know, C sharp, because C sharp uses it quite a lot. The way I think Kotlin has developed it, we in C sharp it's also used almost the same way. In Java, you can also extend something using this way. Like if you have a class string utils, public static string class, like type return type of string to camel case, and then it runs some sort of value over here. The way we do it in Java, and then what we do is string utils dot to camel case, and then the value we pass the value inside of it, and then we return it. Or we could also import in terms of static and call it like a normal method. Now extensions in Kotlin. How could we do that? To camel case in Kotlin, we have function string dot to camel case. It is something different which we have seen previously. Normally, we used to just declare the name of the function, but here we kind of tell that we are going to declare a new extension function for a string class available to us. And then it presumes that this is the value which has to be supplied by the Kotlin compiler to it, and then we replace whatever we want to perform over there. And then we can use it directly like lorem ipsum dot to camel case. That is how we are kind of extending it. And that is how we kind of have an example over here. We declare an extension function over here. We import that extension function over here and we call it here. So, I mean, the question arrives, why do we use extension functions and not a simple function? I mean, why should we use an extension function, and which scenario should we use it? If you actually think about it, that there could be one possible reason where we generally go with the extension functions. It is generally when we want to use a third-party library where we do not have control over the source code written over there. And if you want to extend the functionality of that library, and we do not want to, or we cannot, in short, change the code of that library, we simply can create extensions on different classes which are available in that library, which is pretty amazing and pretty useful and comes in handy whenever we want to write our own custom functions using that. So it's a really good feature of Kotlin which it offers, and the way we write it, it's also quite short in terms of syntax. Next part. Here we see using a list of method over here, we can create a list of these values, parameters, which we pass to the list of, and then it has some extension functions. First is filter not null. Second is filter, third is for each. So you see, each of these extension functions can be used like chaining. Otherwise, if we did not have any extension functions, we could have made them like a normal function, and we would have wrapped the list of with filter not null, wrapped filter not null with filter, and then with for each. All of this should have acted something like it. So it is an extension of iterable, extension of iterable, extension of iterable, and why extensions, which is kind of already what I have talked about. So one more reason for that is we implement solid principles. Why do we use extensions over there? Solid principles, the first principle of it is, it says a single responsibility. Second principle says open for extension and close for modification. And that is what extensions kind of implement in a way, that we do not modify the source code, rather we extend the source code. That is why we use extension functions. I hope that it is not too much for the first session for you guys. I'm trying to concise and use my words in a very simpler way. I hope it should be fine if you guys are listening to me. Moving on to lambdas. So lambdas has a list of, for example, this is the example over here. And then we see we have filter not null, we have filter. We see something strange over here inside of it. We have like curly braces over here. We have something called IT, and then an angle bracket, and then we have IT greater than 2. What is it? What is a lambda? You can call it an anonymous function, which we can pass directly inside a function. So we are kind of passing a function inside another function What do we call that? I think if you recall in terms of the functional programming, it's something called higher order functions, where a function receives another function as a parameter. And that is somehow kind of we are doing it over here. That we are passing id like this inside of this filter function. And that is how somehow we could do it on the fly using these lambdas. It could also be done using this, that you can either close filter and then pass a lambda like this. If the lambda or if the higher order function accepts the function as the last parameter, you can pass it like this as well. What is this id? Id is basically represented an item which could be used by this filter. It iterates through these items and gets the value using id and use it here. But also we could omit this id altogether in Kotlin and make it even shorter, because it presumes that id is the item which is being iterated and looks pretty neat over here. And then you could use something like this in for each as well. Pretty neat. So this is how kind of our lambdas are developed. And I think I am pretty much done with the topics which I had decided for today, because I did not want it to be a very long session, and because Kotlin has a lot of concepts if you want to go with them in detail. So I think from my side, it covers almost all the concepts of Kotlin, and that pretty much sums it up regarding the topics which I had in my mind. So it's a quiz time right now from my side. So uh, just a moment. Okay. I think the first question is, who is the creator of Kotlin? Google, JetBrains, Oracle, or Microsoft? Where would I be able to see the answers over here? If somebody can help me. Answers means answers from the people
Um,
watching the stream.
so it will be shown to you by our host, uh,
Okay.
if it is possible at the first place.
I am gonna await if I can interact with the people who are watching the feed.
Yes, sir. You can wait if you can wait.
How can I interact with them? I'm not sure. Sorry. Should it be here?
So it will be shown to you. Yes, sir,
Okay,
here in the
perfect.
comment section.
Okay, so I already see some comments over here, which I already kind of missed at that time. Certificate, yes, sibling. Okay, I don't know about certificate. Sorry. You can ask about this from the organizers. Hello, everyone.
So thank you, sir, for such an enlightening and knowledgeable session. We all are very grateful to you. Certainly, your experiences and insights in Kotlin helped us a lot. So now the audience can ask their questions regarding the topic in the section only, comment section only.
Yeah, I think I had one last part of my presentation was
Yes,
left.
quiz time.
So I think I have a couple of questions, and then we can
Yes,
move
sir, you can
forward.
ask.
So the first one was, which is JetBrains. I think somebody already answered this. Ayush Ranjan. Good job, Ayush. This is pretty good. Yep, that's the right answer. And somebody, Jayant Rathi. So he also got the right answer. So the next one is, which of these is used to handle null exceptions in Kotlin? A range, sealed class, Elvis operator, or a lambda function? Any answers on this? No guesses? I think the answer for this is Elvis operator. I think you guys might have missed it. It came in between where I was discussing about an operator with this, which is starts with question mark, then has colons to it. And the last question for today is, how to write correct parameters in Kotlin. So these are the four options. What do you guys think the way we write parameters in Kotlin correctly? Take a look at this. I think I got an answer for the previous question, which is incorrect. It's not lambda function, it's Elvis operator. C. Okay, so I'm getting some answers from Sanket, Balani, B, Jayant Rathi D, Rishabh Bhatnagar C, Ayush Ranjan B. So the answer for this should be C. We declare it using function, the name of the function, the value, and the type of that value. So that pretty much sums it up. If you guys have any questions, I am happy to answer those. Any questions from anyone? If not, then I think everybody kind of understood everything, and it was a good session from my side. So I think I have nothing else from my side to explain. Anything else from the side of hosts?
So, thank you, sir, for joining us, sharing your knowledge and experiences with our audience. Now, I would like to wrap up this informative session. Thank you, everyone, for joining us here. Thank you.
You're welcome. Bye bye.